Paloma, are you ready with your presentation?
Hi, I hope so. We haven't had a technical run, so fingers crossed. It all goes smooth. Thanks for the intro, Will. I've been very, very blessed to have worked with Will over the last 6 or 7 years, probably. And long may it continue. All right, let me try and get this up. One second. Okay. Is that working?
Yep, just letting it load. Yep, that's fantastic. Thanks, Paloma.
Great. Hi, I'm Paloma Gormley, as you already know. I'm feeling a little bit under the weather today, so bear with me. I may be a bit slower and more diddery than normal, but fingers crossed we'll get through it. So Material Cultures is working at the intersection of low embodied carbon technology and kind of high performance construction systems. So it's trying to combine, I guess, a lot of kind of historical technology and ways of doing things with more contemporary ones, and to kind of see where that takes us. We advocate for material reform in construction through design, education, and action. We believe that a transition to a decarbonised construction economy is not only necessary, but with it comes an opportunity to radically change the cultures that surround it. We work in a number of ways. So we design buildings, we're architectural designers, and we always look to incorporate technologies or ideas that we think are interesting in every building that we do, and we kind of see each project as a demonstrator. We also carry out systemic research, so we look essentially at how these ideas can scale at a national level, but increasingly at a kind of European scale, and looking at the impact in relationship to landscape. And alongside, or kind of actually woven into that work, we do a lot of kind of teaching and research with students at universities, looking at these problems and developing quite experimental construction systems and ideas. We published a book last year, and it is going back to print today. So there's going to be a second edition coming out, and really it just kind of expands on some of the things that I'll be touching on today. So it should be available again soon. We see the root of many of the kind of problems that face the construction industry today as essentially coming along with the advent of oil and oil-based technology. So there's a kind of trajectory that was set off that in our minds kind of sent us down the wrong path towards this incredibly high input, high energy and fast turnover construction culture. And there's a kind of parallel of this that has taken place in our landscapes with the use of kind of chemical fertilizers that have and industrialized approaches to agriculture that have essentially kind of stripped the lands all of their nutrient value and desertified much of the countryside. So this is kind of our starting point increasingly for all of our projects is the soil and the land, and understanding that everything that we do when it comes to construction has a landscape impact and has a site of extraction, a site of production. It's just so happened that along with that kind of oil-based technology, our supply chains have become so expansive that we've kind of lost that idea of a building coming from a landscape. And I guess the work that we do is trying to kind of reconstitute that and begin to understand again in a way that many of the people in this room on this call will already very, very well know and have been working towards for a long time. But yeah, to try and reconstitute agriculture and architecture and landscape more generally together, rebuild that relationship. I've just seen that my computer is going to die, so I'm going to plug it in before that happens. So this is one of the crops that we think is kind of part of this new approach to landscape. So if we realize that our landscapes have to be thought of differently as well, so regenerative approaches to landscape management, then we're going to have to start thinking about in more detail about the kinds of agriculture that's being supported and the crops, and actually what their relationship is to the soil. Crops like this one are really important, we think, to architecture. I mean, sitting alongside other grain crops, so more traditional kind of wheat and barley and straw. This is a hemp plant, but they're all essentially crops that are grown for their seed, but that produce biomass, plant matter, alongside that cultivation. And the thing that we think is really exciting about straw is its ability to store carbon. So as the plant grows, it sequesters carbon. That carbon is stored in the stem, and then that plant matter can go into buildings where it's stored for a very long time. So you can begin to see a building as a very effective form of carbon capture and storage. Just going to disappear for a second and plug this in. So yeah, I guess we're really interested in trying to get as much plant matter into as many buildings, new build or existing buildings that need renovation or additional insulation, as possible, because the more plant matter you can get into a building, the greater that and more effective that carbon store is. So the hemp plant has two main elements. The inner woody core, known as the shiv, and the outer fiber, both of which are the kind of two elements that I think are really critical in construction and architecture. So combine it with lime and you get hempcrete, which can be cast in situ into a building like this. This is a project that Will was very involved in, and it's actually the project that he just described, plastering. So this is a kind of relatively heavyweight timber frame building. It's kind of 3 or 4 stories high, and it has this in situ cast hempcrete, and you can cast it into blocks. And then we also explored kind of modular prefabricated system, which was actually made at H.T. Matthews, the brick factory. The hemp was grown in the field next door, but then the cassettes and the hemp were put together by Will and Oscar, who's in this photo, at H.T. Matthews and before being brought to site. And then the cladding for the building was the fibre from the hemp plant, so combined with a sugar-based resin to create a corrugated cladding panel. So these building technologies have the ability to kind of far outperform many of the contemporary modes of construction that we've become used to, and I think that's why we find them so exciting. They create incredibly beautiful spaces with much more kind of textural interest and amazing acoustic qualities than the buildings that we're used to inhabiting now, which are increasingly kind of, I guess, bland and devoid of that character and relationship to their materiality. There are also buildings, natural buildings can last an incredibly long time. So this straw bale building is in France, built in France, is now over 100 years old. But what's this got to do with clay? So all of the projects that I've been showing have involved a combination of kind of plant matter, generally hemp, in combination with lime. And as a practice, we are moving away from lime, despite its kind of amazing characteristics and its ability to cure very quickly. It's still incredibly high, really, in embodied carbon. It's kind of one step away from being cement. So we're looking to clay increasingly to kind of, I guess, fulfill many of the same roles, but as a material that's so much lower inherently in embodied carbon because it's not been put through a kind of heat process, and particularly when it comes from the site or somewhere nearby. It's also a material with extraordinary diversity, both in kind of color, but also in performance, and it requires an amount of kind of technical understanding and kind of specialist knowledge, in that you really need to, well, know how to get to know clay and then spend some time getting to know it. And we've been learning a lot from Roland and others about how to start a conversation with a piece of clay. So clay very simply can be made into these kind of adobe blocks, which these are made at H.G. Matthews again. So this is a kind of precursor to a fired brick. You just don't fire it and it can still do 90% of the things that you need a brick to do. Using a clay slip, you can make them into walls. This space also has a very beautiful clay floor, which was laid by Geoffrey Hart, who is kind of one of the UK clay floor specialists. And there's just a quality to these materials that I think is so tangibly rich, and just is not comparable really to many of the more industrialized materials that we've become very used to. So extending our relationship with clay, we've been spending a lot of time at H.G. Matthews. We've been running some kind of hosting construction courses and inviting some of the kind of leading specialists in clay and hemp and other forms of construction to come and teach a group of people. And they've ended up being a really amazing kind of cross-section of characters, from kind of builders to artists to architects and beyond, engineers. And it's been a really rich process of very kind of interdisciplinary kind of conversations around a material and quite an exploratory way of working. So with Roland Keeble, we've been looking at light earth, very much led by kind of his long-standing knowledge of earth and clay. And this material, I guess, is a kind of an equivalent to hempcrete in that it's insulating and has that kind of inherent fire resilience that comes from essentially combining a mineral with plant matter and coating each of those bits of plant matter, giving them both a kind of integrity, but yeah, also this kind of resistance. So on the left we have straw and clay, and on the right hemp and clay. In a way, the exciting thing about straw is that it's more readily available than hemp and doesn't require extraordinarily expensive processing equipment. So in terms of its kind of reach, it has much more kind of possibility, that definitely in terms of kind of self-build projects. So the materials that we've been kind of experimenting with in these educational workshops and courses have been going into this building that's a classroom that we made again at the Brick Factory at H.G. Matthews, designed with a bunch of students from Central St Martin's, and then it's slowly kind of becoming more of a building as we kind of layer up these different technologies. So there's, yeah, on the bottom is hempcrete, on the top straw and clay in the form of light earth, both insulators. And immediately you kind of feel the difference in terms of the kind of working with these materials. You know, lime is caustic, very easily burns you. Clay is just a real pleasure to work with. It's completely safe, you know, you can even ingest it. And it's been a real kind of pleasure for us, just, yeah, feeling the character that each of these different materials bring, and working with a combination of kind of casting in situ and again installing blocks, and looking at how these kind of light earth technologies could possibly scale, and how to make that installation very, very efficient. So this is a kind of prefabricated structure again, where you can imagine that these cassettes could be made again in a factory and shipped elsewhere. And then also looking at finishes, so clay plasters, lime renders, etc. So as an organization, we're really interested in how all of these kind of technologies can scale, and I think clay, as I said, feels really important to us as part of this, kind of integral to this story around plant-based materials, bio-based materials that we're obsessed with, but they don't work unless they're combined with lime or clay. So we really need clay as part of this story. So we've done analysis looking at the kind of relative carbon of a standard kind of Barrett-esque home versus this equivalent home, but built with a completely different material palette. So effectively, you can sequester huge amounts of carbon with the bio-based home, and also in terms of landscape impact, surprisingly minimal. So this is a study that we did in Yorkshire, looking at what a shift of their entire construction economy away from the standard kind of concrete block construction to a plant-based construction, what the impact that would have on land use. And this is the existing arable land area, and this is the area within that would be required to grow the annual, in this instance, hemp crop to supply all of their housing demand for that year. There's a kind of there's a relationship now where buildings almost feel like they have no connection to their landscape. We believe that is something that will kind of inherently return with a new paradigm of architecture, where the materials do have a relationship to place and have traveled less far, and inherently then that construction technology is rerouted, and you have less of this kind of in a way placeless cookie cutter architecture. So we've been working on a project in the south of England, in Lewes, exploring how these ideas and technologies can scale. So we're one of maybe 15 architects working on this large site in the south of the town, and we're developing the designs for around 70 units, and trying to bring these principles which we've developed so far on kind of one-off homes to that larger scale. And then really we see no barriers to that scaling. You know, these technologies are very effective and have the potential to be used across the country. So we're working with local timber, looking to work with hempcrete, and looking to carry out prefabrication on site. So we think the construction industry is at a really important juncture, and materials like clay have the potential to transform the construction industry, so from one of the worst contributors of carbon to one that actually supports the rehabilitation of our landscapes. Thank you very much.
you, Paloma. Annabelle, do we have any housekeeping stuff to say between the
Yes, for
presentation?
those of you who may have joined later, just a reminder that if you can keep yourselves mute during the speakers' presentations, and if you have any questions that you'd like to ask the speakers, if you can write those in the chat, and then after the two speakers finish their presentations, we'll have a Q&A. And then a reminder that we'll be having breakout rooms where you can network with other people here at the conference. There is a description in the chat which will explain how you do that, and there will also be some short films that we'll be playing on a loop during lunch hour. But yeah, thanks, Paloma. That was a great talk. It's really good to see architects getting more involved in the actual materials that they're specifying, because I kind of feel like sort of in the 20+ years I've been doing natural building, it's been very kind of slow on the uptake with architects. I got involved in building a cob house, and we got brought in quite late as consultants, and it just felt like the design didn't really reflect the materials enough, which was a bit of a shame, really. But I'm just noticing in this last kind of couple of years that, yeah, architects are starting to get more excited about, you know, natural materials, but yeah, actually doing some of the building work themselves, or at least getting involved in some teaching element. It's just a shame that it's still not heavily kind of introduced in the, you know, schools of architecture, which I'm not sure why, but yeah, hopefully it'll be on the up.
I think that's beginning to change as well. That I think the schools are opening their doors more to having people like you guys come in and run courses. So yeah, fingers crossed there's more of that too.
Yeah, because I mean, I've noticed it's more like they'll bring people in for a day or a week, whereas to me it feels like it should be massively integrated into, you know, each year of their you know, 7 years of architecture, isn't it, of studying, that there should be some modules each year that relates to getting involved in, you know, looking at the different materials, because it's changing all the time. You know, we've got mycelium, we've got miscanthus. I don't know whether you've worked with miscanthus.
We've done some research projects on it. We haven't put it into any buildings yet, but yeah, we've been looking at its potential as a kind of well, semi-structural material, because it's very robust, really. So that students, I think last year at Central St Martin's, developed a kind of bound column made from miscanthus. It was load bearing.
I've just seen a question in the chat. Hi, Linda. Is Paloma involved in standards in teaching earth construction? Does that have a role in her work?
No, we're not. I think it's something that we're increasingly interested in, is kind of how just one of the key barriers just seems to be how the certification and kind of testing limits really so much the application of so many materials. So I think working and advocating for better understanding of regulators of these materials and how they actually work is something that we'd be really interested in at least contributing to.
So I realise I've just totally done the opposite of what we're supposed to be doing, which is asking questions after the two speakers.
I don't think that matters.
So, sorry about that. We can ask Paloma a few more questions. I've got another question I'd like to ask her, but maybe Will, if you like to introduce Emily, and then we can yeah, have some further questions after that.
Yeah, sure. Well, I just only had one thing to say. I'd never really noticed I found it very interesting when you were talking about the sort of, I don't know if death's the right word, but the sort of dying landscape at the same time as the or farmland, even at the same time as the houses are getting really, really poor quality. And I'd never really made that. I'd looked at houses in their landscape, but I'd never really thought about how the construction industry's gone and this land has gone at the same time, which I found really interesting. And I just wondered, when you, like, did you have a moment where you were like, oh my gosh, these are happening in parallel? And when was that?
Yeah, I think it definitely, yeah, whilst writing that book, it's just a really unusual opportunity to do a lot of thinking, rather than just, doing life. And I think just understanding how linked all of these things are, like the rise of oil, the rise of capitalism, the rise of colonialism, and understanding that those stories are completely woven together, and that these kind of extractive practices that have kind of degraded so many things, all in a way have a kind of common root of this oil-based energy and industrialization, effectively. And that was it was a real revelation for us, and being able to to see what we're doing, also what everyone in this room is doing as really political, and that I think that feels really important, recognizing that
Yeah, certainly, definitely. And how far along is that building now at HG Matthews, the one you were showing with the light earth blocks, and what's next on it?
You tell me, Will.
I've been up there for a while.
I think it's nearly done. I think, Jim gave me a call, very urgent call about windows, which was a positive sign. So I'm going to go in a couple of weeks.
What about floor? Is that going to have an earth floor in it?
Well, maybe we should chat. At the moment, it's just timber cassettes, and I think insulated with cellulose. Not very exciting at all. So yeah, we should definitely have a chat about the floor.
Yeah. Sure. Well, thank you.
I'm told we're running early, so we can still have a chat with Paloma, because I've got another couple of questions here on the chat.
Okay, go ahead.
So we might as well fill the time. Is your research, Paloma, funded by the universities you mentioned or elsewhere?
So it's a real mix. So we we run kind of modules really at universities, and we are paid as individuals to do that education work. So that time is funded by those universities, and we treat those modules as kind of mini research projects, and we're generally working with master's students, and the kind of framing is that we all work together as a kind of research team and produce an output. So we produce projects like one called Carbon Copies, where we took kind of archetypal housing typologies. So there was a terrace house, there was a span house, which is a like 1960s prefab, very good actually housing type. And we translated them, or the students translated them, from carbon heavy materials into low carbon materials, and also upgraded them to contemporary building regulation levels of performance. And that work is available to download online. So those are really great. Those research projects that we do with students are always really exciting and can be really experimental. And then the more kind of systemic research that we do has generally funded and collaborative. So the work that we did in Yorkshire was funded by the LEP up there, Yorkshire in the northeast. And then there was another piece of work which we recently published that was funded by an organisation called Bauhaus Earth, and the work was carried out collaboratively with them. And that project looked at wetlands and the kind of productive potential that comes from the regeneration of wetlands and peatlands. So the kind of exciting thing is that you need to, reed is one of the key materials in the rehabilitation of those landscapes, and you need to cut that reed in order to develop the peat. So then you have this potentially vast stock of reed that can be used in thatching, but also can be used in many other things. They're really brilliant. There's a company called Hisroot in Germany. They make amazing kind of panel products and all sorts. Yeah, so it's a mix. We've also been carried out work with Arab, but it's generally specifically a funded piece of research.
But that's funding. You actually, you're not just giving it, you win the bid, don't you? You know, you have to put work together and say, yeah, we'll do that, and then they pick who they want. And so it's not just like they're, here, Paloma, do this. You have to actually bid for the funding. Is that right?
I wish. I mean, yeah, often, it's a competitive process. We were fellows at Bauhaus Earth, and that wasn't competitive, and that was lovely. not to have to bid, but yeah, we're still quite kind of hand to mouth as an organization. We are not very well funded. It's project by project basis. We have no underlying background funding.
And sorry, Annabelle.
I was just going to say, I don't know whether there's a couple more questions. We've still got some time before Emily's chat.
Okay, go ahead, yeah.
Somebody was asking, this actually says for me, Bucky, but what differences are between limecrete and light earth in terms of construction times and cost? You know, in terms of moving away from using lime with your hemp and then moving to clay, how does that affect the sort of building times and the implicated costs with using a material that takes longer to set?
To dry. We're still really at experimental point in our process, but our process with light earth. But the prefabrication is something that enables us to overcome that. I mean, the same is true with hempcrete, because whilst the lime cures very quickly, it still takes a long time to dry. So in a way, there's a kind of parallel problem there, but something that worked very well with Flathouse, and particularly making it at the factory, was that we had access to these biomass powered drying rooms, and we were able to speed up that process very significantly. But you can also imagine kind of often advocating for forced drying just with fans and air movement. So particularly, I guess, feels like that's where kind of prefabrication could be quite operative in terms of not necessarily causing delays, because you can pre-dry effectively those components. But yes, I can't give you any clear data in terms of relative cost.
I have noticed there's somebody in the chat who I've actually just come across recently, Natural Building Systems, who do prefabricated cassettes. I think it's mainly using hemp, but I don't know whether it's just lime or whether they also deal with clay.
I think that OS speak, well, they can speak for themselves.
They talked about, I mean, it means, I think you can reach a wider audience if you get involved in the prefabricated panels, because you can get in and off sites much quicker, which I think a lot of clients kind of prefer, because obviously natural building is beautiful, but it's slow, and for some clients they find that a tricky kind of element to deal with when they've got kind of short, especially for schools, you know, you might have short time frames in which you can build.
Yeah, well, I think generally we need to change our kind of temporality, you know, and I think that's one of the things that we're learning as well, working with natural materials is slowing down, and I don't think that's a bad thing. You know, again, I think the root is probably in the same issue, that oil kind of sped everything up to quite an unnatural speed, and we expect everything to happen yesterday, and I think just adjusting, I think that's adjusting to a different tempo would probably be good for all of us and the planet, but also would allow for a greater use of materials like the ones we're talking about. I mean, it's also true in terms of, you know, thinking about growing things, and that there's a kind of whole temporality around that, you know, and a seasonality that needs to be adjusted to.
Great. Well, that's, I think we'll be ready to pass on to Emily now. But thanks, Paloma, for that. I hope everyone enjoyed that.
Amazing. Is it okay if I don't come back for the after this session? We have a deadline today.
For the Q&A, yes. I mean, I'm sure if there's any more questions that they can visit your website.
Get in touch.
Maybe if you've got if you want to put your website in details, if people want to find out any more about your work.
Great. I'll do that before I go.
There's Roland is waving his hand. I was just clapping, sorry, I couldn't tell.
We'll put a link to H.T. Matthews' website in the chat as well, because they've been mentioned quite a bit already. You might want to check them out. Thank you very much, Paloma. I'm very, very excited to introduce Emily Kaneko Reynolds now. So Emily Kaneko Reynolds is a passionate natural builder specializing in clay plasters in Japan. She is trained in Japan's earthen plaster works on and off for the past 16 years. She's currently working with a fourth generation plaster company in Kyoto, whilst finishing a PhD in earthen construction. And she's also an author of Japan's Clay Walls, A Glimpse into Their Plastercraft. Now, I came across Emily's book, Japan's Clay Walls, when I was researching clay plasters, before I'd really ever used clay plaster. And I think it's just an incredible book. And it's written so differently from other books. It's kind of a conversation, rather than it's like a conversation as well as a practical manual. It's a great little read. And the more you learn about clay, the more you get from this book. And I also have the latest book as well, signed copy. So I'm completely